So in the previous video we were discussing quadrantal angles. Those are angles in standard position whose terminal ray lies along one of the axes, positive or negative x, positive or negative y. Angles such as 90 degrees, 180 degrees, 270, 360, 450, or the negative angles, so negative 90, negative 180, negative 270, etc. Multiples of 90. And we were talking about defining those trig function values for those angles, sine of 90, cosine of 270. And once again, those trig function values depend upon x, y, and r, and we were looking at the relationship between x, y, and r when the terminal ray approaches those quadrantal angle values. So for example, we looked at what happens as I start to increase my angle theta here. I'm looking at an angle that's approximately 45 degrees. However, when I start moving that ray in such a way that this angle is increasing and going towards 90, we mentioned that, well, what's really happening is the y and r values are getting closer and closer to the same, and the x value is going towards 0. And eventually, when the terminal ray lies right along the y-axis, y and r will be the same value, and x will be 0. And those values, x, y, and r, determine the 6 trig function values. So for example, for 90 degrees, the angle we were just considering, well, the sine of the angle, sine is y over r, and y and r have the same value. So sine of 90 degrees is 1. The cosine of 90 degrees, well, cosine is x over r, but x is 0. So 0 over r is 0. The cosine of 90 is 0. Tangent is y over x. Well, y and r are the same, some non-zero value, while x is 0. Dividing by 0, though, is undefined. So the tangent of 90 degrees is undefined because the x value is 0. And then I can see the reciprocal values for those 3 trig functions. And I can go through a similar process where I rotate the terminal ray around here as I bring the r value over here. I can see, well, what's happening is a terminal ray, I draw that in such a way as it's approaching an angle of 180 degrees. I can see, well, now the x value and the r value are approaching each other, while the y value is getting very small. So x and r are approaching each other, and y is going to 0 as this terminal ray heads towards 180 degrees. So at 180 degrees, y is 0. And x and r have the same absolute value, but because I'm here along the negative x-axis, x is really the opposite of the r value because r is always positive. So x is the opposite of r, and y is 0, and those values help me determine the 6 trig function values. So for example, for 180 degrees, well, for 180 degrees, we know that cosine is x over r, so x over r, well, since they're just opposites of each other, like for example, if r were 3, x would be negative 3, x over r would be negative 3 over 3, or negative 1. The cosine of 180 degrees is negative 1. Well, we know sine is y over r. Well, y is 0, so 0 over r would be 0. The sine of 180 degrees is 0. These 3 values will help me determine those 6 trig function values. So here's an example. Evaluate the 6 trigonometric functions of theta. Theta is 270. Well, 270 degrees. My terminal ray lies here. Again, standard position. Here's my initial ray, terminal ray, and there's an angle of positive 270 degrees. Here along the y-axis, the x value is 0, and y and r have the same absolute value because I'm down on the negative y-axis, y is actually the opposite of the r value. So if the r value were 5, y would be negative 5, for example. Once I have those values in this relationship, I can determine the trig function values. Sine of 270. Y and r have the same absolute value but opposite signs. So y over r would be negative 1. Sine of 270 is negative 1. Cosine of 270, well, that's cosine is x over r, but x is 0, so 0 over r is 0. Tangent of 270, tangent is y over x, but x is 0. Division by 0 is undefined. The tangent of 270 is undefined. And you can also see the reciprocal functions here. So for an angle of 0 degrees, that's also a multiple of 90. That's 0 times 90. So that's a quadrantal angle. If I consider an angle of 0 degrees, x and r have the same value, and y is 0 because I'm along the x-axis here with my terminal ray. And once again, I can use those values and relationships to determine the 6 trig function values. For example, tangent y over x, y is 0, 0 over x will be 0. So the next part of this lesson discusses reference angles. And reference angles are the angles that allow me to determine trig function values for obtuse angles, for angles greater than 90 degrees. Because reference angles are always acute angles. You can see that in the definition, its reference angle, so given an angle, its reference angle is the acute angle theta prime formed by the terminal side of theta and the x-axis. So there are some complicated formulas listed here. However, determining reference angles is really a simple process. You begin by drawing the original angle. So starting with this angle here for 140 degrees. I'm supposed to find the reference angle theta prime for this angle theta of 140 degrees. So I begin by drawing the angle 140 degrees. So in standard position, 140 degrees would mean a terminal ray here in the second quadrant. I determine the reference angle as instructed back here. The reference angle is the acute angle formed by the terminal side of theta and the x-axis. The acute angle formed by the terminal side of the original angle theta and the x-axis. So the reference angle is here, the acute angle between the terminal side and the x-axis. And we know that's 40 degrees. Angle addition postulate, 140 plus 40 is the full 180, the semicircle. So that means the reference angle for 140 degrees is 40 degrees. Similarly, for negative 3 pi over 4, I would begin by drawing the angle negative 3 pi over 4. So negative 3 pi over 4, negative means I move in a clockwise direction. And negative 3 pi over 4, well, negative 2 pi over 4, that'd be negative 90 degrees. So negative 3 pi over 4, that's negative 135 degrees. So I'm here in the third quadrant. Now the reference angle is the acute angle formed between the terminal side and the x-axis. So here's the terminal side of the angle. Here's the x-axis. Pi over 4, that's the acute angle. Negative 3 pi over 4 here. If I continued one more negative pi over 4, that would be negative 4 pi over 4, negative 180, that full semicircle there. So the reference angle in this case is pi over 4. Reference angles by definition are always positive. So the reference angle here is listed as pi over 4, not negative pi over 4. I'm going to pause this presentation and we'll pick up in one more video.